loud. Okay. Thank you guys for attending this session today. My name is Steven Kagesha. I will be taking you through some basics on cybersecurity. And some of the things we're going to be talking about is what is cybersecurity, the differences between between information security and cybersecurity, the CIA triad. I don't know whose mic is on. Cybersecurity domains and red versus blue teams. Please mute your mic if let me see. Okay, we can proceed. But before I proceed, I'd like to ask the audience, what is cybersecurity? You know, I realized most people say the information security, they're in InfoSec, they're in cybersecurity, but when it comes to asking them what cybersecurity is, they cannot be able to, you know, define or explain what cybersecurity is. So maybe someone, I don't know, I pick randomly, or we can have an interactive session. I prefer having an interactive session. So maybe someone can tell us what cybersecurity is, because you choose to be in this. Maybe you can hear from, okay, I think I'll pick randomly. I'll hear from Peter. What is cybersecurity? Okay, I'll take from Ian. Peter.
Cybersecurity, a definition would be that it's just a way to secure systems, really. I think that's the basic definition I have.
Okay. Let's hear from a lady this time. Let's hear from Margaret. Maggie.
Yes, okay. Cybersecurity is meant to protect data, devices, and storage sources against attacks which are in the cyberspace. So I think the main difference between
I'm sorry, I think we lost you quite a bit there. I didn't hear what you said.
Okay, should I start?
Yeah, you can start. I think you are, I couldn't hear your voice at some point.
Okay, can you hear it now?
Yes.
Okay, so cybersecurity is meant to protect data, where data is stored, and the data devices against attacks. So the major difference between cybersecurity and information security is that cybersecurity aims at protecting the cyberspace, while information security aims at protecting both the analog and digital data.
Awesome. Great definition there. So maybe I can share my screen. Yeah, so cybersecurity basically is a practice of defending and protecting computers, servers, mobile devices, electronics, networks, and data from malicious attacks. Or you can also say cybersecurity is a practice of protecting critical systems and sensitive information from digital attacks. So on to the next slide. Margaret has talked about the difference between information security and cybersecurity. Yeah, these two definitions are confused very much with people. And in information security, basically the primary concern is protecting the confidentiality, the integrity, and availability of data. While in cybersecurity, the primary concern is protecting against unauthorized electronic access to the data. Yeah. So in the previous slide, we talked about in information security, we have said it involves protecting the confidentiality, the integrity, and availability of data. So there's something called the CIA triad, yeah, which is basically a model designed to guide policies for information security within an organization. So basically, CIA triad is like the pillar of security, yeah? And as you can see, we have confidentiality, integrity, and availability, whereby confidentiality basically are the measures designed, yeah, to prevent sensitive information from unauthorized access attempts. It is common for data to be categorized according to the amount and the type of damage that could be done if it fell into the wrong hands. So more or less, stringent measures can then be implemented according to those categories. Yeah. So when you talk about integrity, it basically involves maintaining the consistency, the accuracy, and trustworthiness of data over its entire life cycle. Data must not be changed in transit, and steps must be taken to ensure data cannot be altered by unauthorized people. For example, in a breach of confidentiality. Yeah. We also have availability, which means basically availability means information should be consistently and readily accessible. Yeah, for authorized parties only. Yeah, this involves properly maintaining hardware and technical infrastructure and systems that hold and display the information. Yeah. Up to that point, I don't know whether we are clear. Okay. On to the next slide. We have something called domains, yeah, in cybersecurity. Cybersecurity is very broad, yeah. And most people, most people think that when you say you're in cybersecurity, you might be very good in hacking, you might be very good in a lot of things in cybersecurity, but most people don't know really about the domains, yeah, in cybersecurity, yeah. So some of them include security and risk management. There's asset security. Sorry, someone has a question? Okay. We have security and risk management. We have asset security. We have security engineering. We have communications and network security. We have IAM, which is identity and access management. We have security assessment and testing. We have security operations, and we have software development security. Yeah, we're going to be tackling each of these domains briefly, and maybe you can research more after this session, in-depth knowledge about the 8 domains that I've talked about. Yeah, so we have security and risk management. Basically, this domain provides an overview of information systems security management, and it covers areas such as principles of security governance, compliance requirements, legal and regulatory issues in information security. We have risk-based management concepts, and we also have the availability, integrity, and confidentiality of information. So you can see the confidentiality, integrity, availability quite a lot in your career or in your cybersecurity journey, or even if you choose to pursue certification, asked quite a lot, yeah, to demystify. We have the next thing we have is
Excuse me.
So basically, it covers physical requirements, and it covers things such as classification. Yes. Yes, someone had a question?
Stephen, it reaches a time you are
We have
breaking.
asset security. which includes the physical requirements.
Yeah. Sorry for that inconvenience. Before we wait for him to come over, maybe we can just a review of what he was sharing. He was looking at the principles, or rather the approaches that can be used in understanding the field in the cybersecurity. Just a moment. Yeah, so he was talking about security and risk management. So at that point, maybe any one of us could try to give us a brief description. What is a risk? Anyone who can try to answer that question?
Can you hear me? Can you hear me? A risk is a possibility of harm to a system or to information.
Yeah, that is a good attempt. Possibility of harm. Yeah, so it's something like a probabilistic approach that can be attached to it. So anyone else maybe who can give us another description, or rather how you understand it? Yeah, he's now back. So anyone else who can give an attempt? Okay, so in simple terms, we can say that maybe a risk is a probability in which a threat can use a vulnerability that may have been observed in a system, different various kinds of systems, in order to attack it to achieve a specific goal. Yeah, so with that, I believe you can be able to understand it from that approach. Steve, kindly take us through from where we were. Yeah. Hello, Steve.
Okay, I'm very sorry about that. I think my internet disconnected for a moment. Communication breaks again. Kindly tell me so that maybe I can buy bundles or something. Yeah. So let's continue. As I was saying, we have it generally asset security basically covers data security controls and classification or ownership of information, and security engineering, which covers the designing and implementing physical security. Someone else is. Okay, which covers designing and implementing physical security. We have assessing and mitigating system vulnerabilities, and we also have using security. So some of these terminologies might sound foreign, but we will be tackling them quite a lot, yeah, in the coming few days or the coming few sessions, or you can still do more research on them. I'll share this PowerPoint presentation, which has quite some notes in it, apart from the ones you're seeing here. So we also have an organization protected. Yeah, we have secure network components, and secure design principles for network architecture. Is identity and the way users can access the data within the organization. It covers things such as authorization mechanisms, identification and authentication, physical and logical access to assets, among many others. We also have security assessment and testing, which focuses on the performance, the design, maybe Kevin, you can proceed a minute before I buy bundles.
Yeah, sorry for that echo. So we were at, okay, I can see that it was mainly covering about security assessment and testing. So as it is written, it focuses on the performance, design, and analysis of security testing. So the first aspect is performance. So you'll come to realize that some issues can be mainly mitigated by the improving the performance of various systems, because you cannot put up security measures in a weak system that has very few resources that are to be used. Remember that there is a system that is supposed to be functioning, and also there is now the security measures that guard those systems. So for instance, you can have a firewall that is guarding an ERP, that is an enterprise resource planning system. So as much as you're trying to secure it, you should also have good resources that are performing very well. Also, design, you'll come to realize that the architecture in which various systems have been made can call for a replanning, or rather going back to the drawing board, so that you can be able to understand what can we do in order to improve it. Sometimes you may find that you'll have to go back to the process of planning it again. So as much as possible, when you are trying to do your security assessments, or you should also, along the way, you should recommend to them that they should have systems that are flexible. Yeah, Steve, could you now be ready on your side?
I think I'm okay now. Yeah, so sorry for that. So back to security assessment and testing. We have said that it focuses on performance, design, and analysis of security testing. And it covers areas such as internal and third-party security audits, designing and validating assessment and test strategies. We also have security operations, and this domain basically addresses how plans are put into action. Concepts covered here include business continuity, managing physical security, disaster recovery, and incident management. Yeah. So in the coming sessions, we will be talking about things like the disaster recovery plans. We will show you what and how a disaster recovery plan looks like, how a business continuity plan looks like. We will show you all these documents, which are very relevant in organizations. Each organization, basically, that you know of, or most organizations are required to have some of these documents, such as the BCP, the business continuity plan, and the disaster recovery plan. In case an incident or something happens in the organization, they have a playbook or like a documentation that they can use to get back to the position or the posture they were in before they were attacked or affected. Yeah. So we also have software development security, which covers or which helps cybersecurity professionals understand, apply, and enforce software security. And it covers areas such as secure coding guidelines, or involves things such as secure coding guidelines and standards, effectiveness of software security, security controls in development environments, and security in the software development lifecycle. Yeah. So something else, I don't know whether this is visible. We talked about something called the red versus the blue team. Maybe someone can tell us. Actually, let me get 3 responses about this question. Let me see the participants. Someone can tell us the difference between a red team and a blue team. Anybody?
Okay, I think I can contribute to that.
Okay.
So red team is involved in the offensive security operations, while the blue team is involved in the defensive security operations.
Okay, thank you. Someone else? Someone else can try. Okay, maybe I can proceed. Someone, okay, Douglas. Douglas? Okay. So we have red teams and we have something called blue teams. And we have also other kind of teams that I'm going to be talking about later, or might give a general overview of the same. We have red teams. So what are red teams? First of all, there's a difference between red teams and penetration testers. People often confuse these two, and there's a difference. Red teaming is basically the act of systematically and rigorously, but ethically identifying an attack path that breaches the organization's security defense through real-world attack scenarios or real-world attack techniques. And some of the activities performed or done by red teams include emulation of TTPs used by adversaries. The target is likely to, emulation of TTPs used by adversaries, the target is likely to face, for example, using similar tools, exploits, pivoting methodologies and goals as a given threat actor. Yeah, so they will try simulate something like, let's say we have threat actors from APTs from China or APTs from Russia, and we know that they are used to maybe attacking using maybe through phishing or using some specific tools. They will try simulate that, yeah, and use some of the exploits that the threat actors use, and those pivoting methodologies. Yeah, basically that's what they do, threat emulation, and we have something called campaign-based testing, which runs for an extended period of time. For example, in weeks or months of emulating the same attacker. Maybe, I don't know, I'll show you on I'll show you at the end of the presentation what I mean by red team activities and some frameworks that the red team and the blue team activities use. We also have blue teams, which are the proactive defenders of an enterprise. Enterprises' use of information systems by maintaining its security posture against a group of mock attackers. So basically we have the red team and the blue team, they work hand in hand. So the red teamers try to simulate an attack, and the blue teamers try to kind of defend, yeah. And some of the activities performed or done by the blue teams include understanding every phase of an incident and responding appropriately. We also have, they do stuff like security audits, log and memory analysis, and other things like reverse engineering, yeah, let's say of malware and such kind of things that are deployed or that are maybe sent by attackers or the red team. So let's say, for example, in reverse engineering, some of the things that the blue teamers tend to achieve from reverse engineering, stuff like malware or maybe even log analysis and memory analysis. Some of the things they try to achieve out of that is getting things called indicators of compromise, IOCs. So let's say, for example, there was let's say on a user's machine, a user clicked on a malicious file and downloaded a malicious file. And what the blue teamers will try do will try get that file and test it and try to reverse engineer it in a sandbox kind of an environment, yeah. So they will try to see and try understand what that malware does, what that exploit that has been deployed, what does it do really, yeah. So they'll try get some things like IP addresses to some of the command and control servers that attackers use, and they will use those IP addresses and also, okay, they will use those IP addresses in things called SIEMs and endpoint detection systems, so that they can try see whether did that malware try spread in the whole network or the whole organization, yeah. So those are some of the things that blue teamers tend to do. We also have other kinds of teams, but the red and the blue team is are the major teams, yeah. We have someone called Daniel Misler. He has I don't know whether to call it a framework, but he has this pyramid here. It's called the bad pyramid, where we have you can see we have yellow, we have green teamers, we have purple teamers, we also have orange teamers, which maybe are not quite relevant in this context, but yes, it's good to know that there are other kinds of teams. Yeah, I'll share this. I'll share this link in the chat, or maybe so that you can try understand more about the other kinds of teams on your own free time. Yeah. So that was my short presentation on introduction to cybersecurity. You might wonder, why am I talking about some of these things or concepts? Yeah. But maybe seem so foreign or so complex, because I tend to think most people are not quite familiar with these concepts, and maybe you'll end up landing yourself in a very nice job, maybe in Safaricom or whatever. But then you'll come across things like maybe you can try go back. You'll come across things like business continuity plans and disaster recovery plans, information security policies, and you'll be like, hey, I only know how to hack because I am very good in hacking, but when it comes to the theoretical and the corporate side of cybersecurity, most people don't have that understanding. So I felt like in this session, I could kickstart you with a few basics on and some of the concepts that you need to know as you progress in your academic or cybersecurity journey. Yeah, I might have missed quite a lot in this presentation, but I have structured to cover the same in the upcoming sessions. So don't worry about that. So cybersecurity is basically so broad, yeah. So when you think about, I'm trying to break it. I'm trying to break it down into different ways and different into different ways, because the first method I've introduced you to is the difference between the red teamers and the blue teamers. You know, the attackers and the defenders. So maybe next week I'll try talking about some of the, I don't know what to call them, paths in cybersecurity, because cybersecurity basically is generally broad, so broad. We have things like web security, yeah. We have mobile security, we have malware analysis, we have cryptography, we have network security monitoring. We have a lot of things that we can talk about. We'll cover them in the next session. So don't worry, maybe I've not mentioned some of the things, but basically that's all I had to share for cybersecurity, for the introduction part of this session. Yeah. So in the interest of time, I also had another presentation on Docker. Maybe I'll stop sharing this screen. Just a moment. Yeah, I don't know whether you can be able to see my screen. Can anyone confirm they can see my screen?
Yes.
Okay, awesome.
Yeah, you can see it.
Awesome. So last week, I think it was last week or last week but one, I introduced you guys to Docker. And today we're going to be doing part 2 of Docker. Just a moment. So page 18. So I feel like this screen is so small, so I'm going to try SSH into the machine. Okay, I don't know why it's not. Let's see. Screen, let's share this one specifically. Yeah, so unfortunately, I don't know. I can't SSH into the session for some reason. I'll figure it out later. So let's see. Let me pull my notes on Docker. All right. So I think we can start. So I assume that you guys installed Docker on your systems, right? Did anyone manage to install Docker?
Yeah, it was successful on my side.
Okay. So we can proceed. Let's say we want to check. Let me just go back to the route folder. Let's say we want to check whether the Docker daemon is running. Yeah. So we'll typically run something like actually let me just right. Wanted to check whether the Docker daemon is running, we will run systemctl status systemctl status then Docker. Yeah, and we can see that it is active and it's running. Yeah, it's up and running, and it's if we wanted to stop this service, we'll still run this command, but instead of status, we can say something like start. Sorry, if we wanted to stop the service or the daemon, we will do something like stop. And if you wanted to check its status, you can see that it's inactive. Yeah, it's dead. So once again, if you wanted to start the service, I'll typically do something like start. I'll take a second or a minute. Yeah, from there, we can check its status again, and I believe it should be active and running. Yeah, so that's how you check whether the Docker daemon is running. Yeah, right. So something else you need to know is to check whether, let me run that command again. You see, it's up and running. Something else to note, something else that you might want to configure is, you see here it says enabled. What does this mean? If you want this service to be started automatically every time you boot your machine, you want this service to be automatically up and running. You'll typically have to say something like systemctl, then you need to say enable. Yeah, enable. Then you need to enable the docker.service. Sorry, docker.service. Yeah, that will take a minute. And if you check the status, since it was already enabled, you'll still say it is enabled. Yeah, but if you wanted that every time you boot your machine, you want to start the Docker service manually, you can choose to disable it. So instead of enable, I believe it should be disabled. I think it should be disabled. Yeah. Right. Let's check its status once again. Oops. I think it's still enabled. Oh, yeah, it's disabled. The Docker service, docker.service is disabled. Yeah. But you see, at the end, we have something else that is still enabled. That is the container service. So if you wanted to disable the container service, you will run the same command, but this time round it will be container. No, let me just clear it out. It will be container D. I believe it should be container D. Yeah, container D dot service. And try clear the screen again. Check the status. Yeah, it's actually enabled again. I think I need to restart the whole daemon. But basically, that's how you enable and disable the Docker service and the Docker container. So I'm going to enable it so that we do not have any issues later on. Right. So back to Docker. That was about the Docker daemon and the container D service. Yeah. If you're new to Docker and you don't know how to use Docker, it is always recommended to use the manual, yeah, the Docker manual or the help option to be able to see some of the commands that you can run, right? So to access the Docker manual, you simply type Docker, and it will give you a whole list of some of the things you can do with Docker. Yeah. I'll try scroll up. So we have, you can see we have different options, different management options. For example, we have image. We can manage images using the image command. We can manage networks using the network command. We can manage the service using the service command, etc, etc. And some of the commands that we are going to use are listed here. We are going to talk about some of these commands. For example, attach. We have something like images. We have inspect. We have pull. We have push. We have RM. We have quite a lot of commands that we can use, right? So I'll open a separate tab. So I'm going to use this tab for the help option, and I'm going to use this tab for actually trying some of the things that we're going to be talking about. So if we wanted to list what images we have in our system, we'll typically run Docker images, right? And it will tell us we have an image called Oste, my toolkit. We have another image called Ubuntu, and we have another image called Yetiforce. Yeah. And once again, once I go back to the help option, you see the images command. It helps you list the current images. Yeah. So maybe some another command we can try use is Docker PS. Docker PS. What this command does, you can check the manual. It lists containers that are, that are up and running. And currently we can see that we do not have any container that is up and running. So what we can try doing Docker PS tag A, which will tell us, okay, we have 2 containers that were running. Okay, first of all, yeah, we have 2 containers that were previously run. We have the Ubuntu, and we have another one that doesn't have a name. Yeah. So, but how did I get to use Docker PS stack A? And PS stack A is not listed here. If you wanted to see what else we can do with a certain command, we can do something like Docker PS. Then we can do help option to see what other things we can do. So Docker tag A, it basically shows you all the containers. Yeah. So it shows you all the containers. Basically, let's say like the whole history. Yeah. And you can be able to see some of the commands that were run for specific containers. Yeah. So that's how you use these commands, and how you can also use the help option with specific options. For example, if you wanted to see whether we have other options for Docker images, we can do something like we can have Docker then images, sorry for the typo, images, then tap help. And you can see we also have other options that you can append to the Docker images command. You see, for example, Docker images, then you can do something like A, you can do something like quiet. So there's quite a lot you can do. So it's always good to explore the help page if you are not quite sure with what to do. We also have another command called info. Info is info. Yeah, it displays the system with information. Yeah. So let's say something like, let me clear my screen. We do something like Docker info. It will give us basically everything about. You can see information such as how many containers that are there that are currently or previously run. We also see that we have the Docker version listed here. We have the number of images that we have, the number of containers stopped, and many other things that depending on what you want to know or what you want to check, that's how you get to know the system-wide information where you have installed Docker. You can basically run Docker info and you get all this information. You see the amount of RAM allocated to this PC, the OS type and the architecture, and the operating system hosting the Docker service. Basically, a lot of information. You can get a lot of information using the Docker info command. Yeah. So something else that you'll be interested to check is Docker network. Yeah, I don't know. Let me see. We have Docker network. I can see Docker network. Okay, let me try that again. Anybody seeing networks? I can see it here. Okay, we don't have networks, but basically we can do Docker network and maybe something like help option. Yeah, we get more information about the network command where we can try connect a container to a specific network. We can try disconnect. We can try inspect a specific network. We can try list all the networks that are available. So maybe we can try a few of these things. We can try first of all run Docker network, and it will, sorry, yeah, Docker network inspect or Docker network ls. Docker network ls tells us that we have 3 networks. You see 3 networks. We have the bridge, we have the host, and we also have something like the NAN. So by default, the network used by Docker is a bridged network, right? And if you try doing something like if config to check the IP address, you will always notice there's a default IP assigned to our Docker adapter. So you can see it's 172.17.0.1. Yeah. So if you wanted to inspect more about the this specific network, the bridge network, we can do something like I believe we can do Docker network. Then you can do something like inspect. Since we saw one of the options that we can append to network command is inspect. Yes, we can do inspect, and we can try inspect. We can use the name, or we can try use the network ID. In this case, I'll try use the network ID. Maybe you can see some information about this network. Yes, we can be able to see more information about this specific network. We can see it's called bridge network. We can see other options such as the subnet, which I've showed you here. Let me do that once again. If config, and you can see the network is 172.17.0.1. Yeah, so basically that's how you get to inspect a network. You can see the subnet, the gateway, and many other things. Yeah. Also, we can try create our own network, but that's beyond the scope of this class. Maybe I'll handle that in the next session. We can clear that. Then another command we can try using apart from networks is search. So what does the search command do? Let's see. We have the search command. So if I wanted to get a specific image, yeah, if I wanted to get a specific image and I don't have it currently in my repository, this is what we mean by your local repository, Docker images. So what you're currently seeing here, this is my local repository. Yeah, we talked about the Docker Hub. I showed you the hub.docker last time. So that's the public repository, and this is our local repository. Just how similarly to GitHub, if you wanted to upload your code, you basically push your code to GitHub, and you can also have your local repository in your machine or something like that. So let's say we wanted to look for a specific image and we don't currently have it here. For example, we can look for an image like we can try run something like Docker search. Let's think of an image like if I wanted to learn more on web security and I wanted to use the dumb vulnerable web application, I can try see whether someone has already created an image of the same and uploaded it to the public repository. So I'll try search for that specific image. Let's see whether we can get it. Docker search DVWA. Yeah, there's a problem with what? Oh, there's a problem with my internet connection. Let me see what I can do. Just a moment. Yeah, I think this should work. Maybe can try SSH once again. Yeah, I think this should work now. Just a moment. Yeah, I think this is better. I think this view is better. The other one was quite disturbing quite a bit. So we can do it from here. I believe my screen is visible, right?
Yes.
Anybody? Awesome. We're doing Docker search DVWA. I think that should work. Yes, we can see that we have already queried the public repository, and we have seen that we have several containers. Sorry, we have several containers on for DVWA. So one thing to note is you can see some of these things. You can basically choose, because there are very many options, you can basically choose which one you like to pull from the repository to your local repository by looking at some of the things like the stars. You see this one has a high star rating of 69, right? In other images, you can also check the official section. In this case, there's nothing listed as an official image, so we can maybe try search for another image like let's see, CentOS. We can try get another image like CentOS. Let's see. Yes, you can see when we did search for CentOS, we can see that it has a high star rating and that it also is an official image. So this I'll be particularly interested in getting this image. So in this case, what we can do in order to get this image from a public repository to a local repository, we can use the pull command. Yeah, and how do we do this? Let me clear my screen. We can do docker pull CentOS. First of all, let me first of all run this docker images so that we can note the difference. Docker images, yeah, we can do docker pull CentOS, and it will start pulling this image from the public repository. Yeah, maybe you can try open another tab here. This is image. Try open another one as well. Yeah, that should work. So clear. So it's taking quite a bit of time to load. So let it just finish as I. So maybe I can try show you from the search results what I meant by an official image. I'll pull up hub.docker. Oops, typing error. Yeah, you see that we have several instances of the Docker of the CentOS variation of CentOS image. So one way to get an image, basically you can come to hub.docker and manually search for a specific image, or you can query it directly from your terminal. Yeah, let me do that again. Docker search CentOS, and you'll get pretty much the same results. Yeah, so we saw the first one is an official image and has a rating of 6,000 and 6,000. And you can also see the same here. So basically this is the official image, and we have other variations such as custom web. I don't know whether it's listed here. Is custom web, that's still an instance with the same. Don't see here. Maybe we can try yeah, so we can see already when you come to the official image, it tells you the command that you can use to pull this image to your local repository. I want to see other flavors of Docker. Yeah, they're not listed here, but basically this is the official image that we are getting. So one way to do this is through the terminal or through the browser. Yeah, I don't know whether it has finished. Yeah, it has completed. It's extracting. Awesome. So we have managed to pull this image. We can try running the first command, this one, Docker images again. We can try run that again. And you can see this time round that we have managed to get this image. Yeah. So if last time I think we talked about how images in Docker can be very small. As you can see, CentOS, the whole image is basically 200 MBs as compared to how you'd have downloaded it from the official site. You'll probably get CentOS for something like 4 GB or 3 GB, but as you can see, images in Docker are relatively very small. Like you can see, an Ubuntu image is only 772 MBs. Yeah, so we have managed to get that specific image successfully. And if we wanted to now run this image, yeah, if we wanted to create a container out of this image, we'll do something like Docker then run. Then I'll do something like IT. I'll explain what IT means. And we also, in this case, we can do CentOS. It's not auto-completing. Okay, CentOS, which has a tag of latest. It is important to know about something called the tag. So let's assume that I had different we had different variations of CentOS that let's say we had Ansible CentOS, we had console CentOS, we had all these kinds of CentOS listed here, but we wanted to run a specific image. A good practice is running using the repository name, and you also append it with the tag by using the, I don't know whether it's called a semicolon or, yeah. That's basically how you run the container. I said I'm going to be talking about what the IT means. Basically, this gives you an interactive shell. We can try look at a few. I can clean screen. Docker run. Then you can try help option to see what options are there. We have the first one I used was I combined it. Yes. It gives you basically you want to run this command, yeah, and get an interactive shell, and T spawns a TTY shell, yeah. So I believe by now we have managed to run this container, and as you can see, automatically you're running it as a root user. Yeah, we want to confirm, we can do something like ID, and you can see we are root, right? We can try create a file called test.txt. Yes, and maybe you can try see where we are in the root directory, and let's see whether we have that file. Yes, we have it, test.txt. Awesome. So you can try write some content into it by doing echo file. A test. Yeah. We will output it to the test file, and we can try see whether it actually did so. Yes, it managed to do so. So one thing you can do, you see, okay, we are already in a container, right? And you might want to exit this container, and one way to exit this container is you can completely choose to, I don't know how to explain it. you can choose to background this container so that you can run it again, or you can choose to discard it like completely. I'll show a demo. You can do something like exit, which basically terminates that container. And if you do something like Docker PS, we can see that it's not currently running. But if you check at the history, Docker PS stack A, it will show us, okay, we created a container called, I'll talk about naming system later, but we created a container 2 minutes ago, and the current status is that we have exited the container. So we can choose to go back to this container at a later date, or you can choose to delete it. Yeah, I'll show you how to do that. We can also run a container. I'll run the same container, but now I'll use more functionalities. For example, we can do Docker run and I want an interactive session, and I want to use this image called CentOS to build a container that has the tag latest. And you can also run actually a command towards the end. Yeah. For example, I can do something like I want a bin bash shell. Yeah. Or maybe I don't know whether I can do ID, whether it will show me something. Let me see. We can also do something like, yeah, you can append a command towards the end of your Docker run command. Yeah. And it will give you a specific, something specific. For example, if you wanted a shell, if I just wanted to run the container without any commands, I'll typically do this, like how I had done before, right? But if I wanted to run some commands, yeah, you can do that towards the end by maybe doing, for example, if I wanted to, I don't know, I cannot do that, but we can, as you can see, when we run a command like ID, it tells us that we are running as a root user. But for this case, and in most cases, I like running it with bin bash. Yes, and it gives us a shell. And maybe I can, I don't know, clear my screen. I cannot clear the whole screen. So since we are currently running this container, if we wanted to check if it's running, we can do something like Docker PS once again, and we should see it listed here. Yeah. But if we exited this container, if you do Docker PS once again, you will not see it there. Yeah, you will not find it there. But if you look at the Docker PS stack A history, you will see, yes, this container that we had run, we actually exited it 9 seconds ago, right? So I wanted you to get how to, first of all, run a container. Yeah, how to exit a container, and how to check the status of a container. Yeah, so I think from here we can proceed. Something else I wanted to cover is the naming convention. Let me maybe make this a bit smaller. I'll run that command again. I want to talk about this naming convention. If you don't name your containers, it will Docker automatically assigns some funny names to your containers. Yeah, for example, we can see we have Galant Richie, we had Adoring Da Vinci, but we can choose to run our containers and using names. For example, we can also try create another container. There's no harm in creating another container. This time, maybe I can try create a container out of an image, Ubuntu image. Sorry, Docker images. Oops. Docker images. Let's create a container out of Ubuntu. To do so, we can do Docker run, and I want an interactive session. Then, in order to name your containers, you now use tag name, right? And we can call this container maybe test server. Yeah. And we want to run this container out of Ubuntu image, which has a tag of latest. Yes, and also my command, I'll use a bin bash command, and we should have the container created. Yeah, if we want to see if it's actually up and running, once again, Docker PS, it will tell us, yes, we have created a container based on the Ubuntu image. And now this time round, when you look at the naming section, convention, you can see that it applied as a test server. Yeah, I think it can be very confusing if we have if you are working with, okay, this is a bit smart. It can be very confusing if you are working on a serious production environment and you just have you have your containers with very funny names. You cannot easily remember, okay, I was working on a container called this and this and this. So it's always a good practice to give your containers names. Yeah, for this instance, you can see we have test server. Maybe we can also try create a production container, but we'll do that with time, right? So Let's say, okay, let's have this container running. Let's say we have, okay, when you did this command, docker ps stack A, you can see some of the containers were stopped. Yeah. Let's say I want to go back to the first container that we created that had a test file. Yeah. How do we do that? Since we have already, the status shows that it's currently exited. We can do so by using the docker start. We can use the start command. Yeah. And maybe you can check some options that we can append to the start command using this docker start help, and we should be able to see that we can be able to attach. Basically, we get a brief description. This command is used to start one or more stopped containers, and these are some of the options that you can use. Yeah, with this command. For this case, I'm just going to run it without a lot of additional options. So I'm just gonna do something like docker start. Then, if I wanted to start this container, I can use something called the container ID. Yeah, I can use this container ID, or I can also choose to use the weird name, which is Adoring Da Vinci. Yeah, so I'll do two demonstrations of this using both. Yeah, so let's start with Adoring Da Vinci. If we do that, that should start that container. Maybe we can try check its status. And as you can see, we have already managed to start that container, and it's currently up and running. Yeah, so that's how you start an exited container, right? So we can also start another container, but this time around you're going to use container ID. Yeah, that is actually running. So let's use this one. No, let's use this one. Yeah, you can also choose to use the container ID. So if you check current, if you want to check the status, docker ps stack A again, and we should see that it's up and running. Yeah, so basically we have two ways of starting a container, using the container ID and using the naming convention towards the end. Yeah, so that is how you will start containers, but we have only started these containers. We still don't have a shell in each container. For example, I want to get back to this specific container. Where is it? Yeah, this specific container, the Adoring Da Vinci. I want to get that shell. So in order to get the shell, we need to use another command called attach after using the start. So we will do something like, let's see first, docker attach help to see whether we have any other options that we can append to that command. So docker attach is used to attach local standard input, output, and error streams to a running container. So in this case, we are not going to use any of these options, but we are going to do docker attach, and I'm just going to use that name again, Adoring Da Vinci, and we should get a shell back. Yeah, I want you to notice the difference. You see, the first one was my local machine, and this time around we're back in that shell. Yeah, and I can do ID again. We are running as root. Okay, we can try look for that file again, cat test.txt, and we have it again. So if you have a container that is stopped, yeah, and you want to get back to it, you basically have to do the start first command, and you need to also do the attach command, right? So I believe until this point, sijatupa mtu. Maybe someone can comment there or chat or say something. I hope we are flowing. I don't know whether we're flowing. Faris. Ian. Ama watu wameenda kukula. Ian.
Yes, we are following.
Awesome. And I hope si ngumu. I believe it should be a very fun topic.
Okay, still.
Yes.
Yeah, it's fun.
Can you repeat that part about attaching?
Okay, attaching. Okay. Okay, let's exit out of this container again. Higher. You see, we have managed to get a shell in that container, but we have exited once again. Yeah, meaning that if you look at the current status again, Docker PS stack A, we should see that it's exited. Yeah, during DaVinci, once again, we have exited it 13 seconds ago. So typically, in order to get a shell back to that container, you'll have to start with you'll have to start with Docker start. Then I'm just going to use that name again, during DaVinci. You basically, first of all, have to start it. Once you start it, maybe you can check the status again. So that command, I want that command to stick. That's why nairudia mara mob. So when you check at the status again, you can see that it's up and running this time and not exited as before. So if you wanted to get a shell back, we use the docker attach command. And maybe in order to understand, I don't know, let's see, docker, we should have attach here somewhere. Yes, docker attach, and basically that's what it does. It attaches, it basically gives you or spawns a shell for that container, right? So I will do something like docker, then I will do attach, and that specific one, it's called adoring. For some reason it's not auto-completing, so I'll just have to, yes, and you can see that we are back in the container, and you can try also see whether we can get that file. Yeah, and it's, yeah, basically that's how you start you start and attach to a container. I don't know whether it's clear, Maggie.
Yes, it's clear. Thank you.
Okay. Awesome. So I am in this container, and this time around, I don't want to exit it. Yeah. Let's say, for example, you see, when I'm in my container, or maybe let's say you're having a server, yeah, running on the cloud. You know, if you're running a server on the cloud, and maybe you don't have, let's say it's like an Ubuntu server, yeah, and that's why you've installed Docker. So you don't have like the graphical user interface. That's why you're seeing. I like using the SSH. I like to SSH to this Ubuntu machine as opposed to just using it directly. So that it can be easier to understand it better. So let's say, for example, I wanted to get something from my local system, or I wanted to do a specific task on my local system, but I'm inside a container and I don't want to exit this container or terminate it. But what can I do? So instead of typing the exit command, what we can do in this case is, for example, you see, I cannot run the clear command to clear the whole screen because I'm inside a container. I'm constrained in that container. But if I was on my local system, if I wanted to clear the whole screen, I just run the clear command, and yeah, and you just exit and you just clear the whole screen. So actually, this is a container. I don't know how I've cleared the screen. Oh yeah, it's because I had run some commands on it. So I want to exit this container without terminating it. What I can do, I will hold Control P, then Control Q again. Yeah, at the same time, Control P, then Control Q. And you can see this time around that we have managed to get back to our local system. But I believe this machine should still be running. So we can confirm by doing docker ps stack A, and you can see that it's still up and running. Yeah, if maybe you can try running the docker ps alone, we should see that it's actually still running. Yeah. So that is how you background a container so that you can continue doing stuff on your local machine. And once again, if you wanted to go back, you can use the docker attach command. Yeah. So that's how you do it. Yeah. Higher. Let's try something else. Let's try something else. what can we try? We can try, I can show you how to rename a specific container. Let's work with one container that's already stopped. So we have this container called called new name. Yeah, we have this container called new name. Let's say we wanted to rename this container at a later time. Yeah, so how will you go about this? We can, when you check, actually it's not listed here, but it's good to know we have a command called docker rename. So I'll clear my screen first of all, then I will do that again. So we can use the rename command, docker rename, and let's rename this file from new name, and this time around I want to call it maybe prod server. Yeah, or yeah, kitu kama hiyo. So we just need to run docker, then the command rename, then the current name and the name that you want to give it. So simply executing that and checking the command history again, we should see that we have managed to rename that container. So that is how you are going to go about going to go naming containers. Yeah, so I'll try. I don't know that. Can you hear me?
Yes.
Yes, sure.
Okay. Something else I'm going to show. Okay, and maybe you should have guessed it right. You use the rm command. Yeah, similarly to how you would have done on your on a typical Linux command line. So we have the docker rm and we have the docker rmi. These are two commands that you should be very careful using them, because you might intend to remove a container, but you end up removing an image. Yeah, so I want you to remember that rm is for containers and I towards the end stands for images. So RMI is for removing images and RM is for removing containers. Yeah, so don't confuse those two. So for this case, we can try removing one container. For example, the ID one, the one that had a command run as ID. We can try removing it by running docker rm and something like, instead of using the name, let's use the container ID. And you can see, I think it should be successfully removed. We should not see it this time around. Yes, we have managed to remove it completely. That's how you remove containers. Yeah. So that is how you remove containers. Something else I can also show you is inspecting specific containers. Yeah, you know, before I showed you how to inspect a specific network, maybe running something like, let me exit out of this container. But actually, let me just background it. Yeah, I think we're back to our system. Okay, so I showed you how to run the docker inspect. Docker, sorry. Just docker network. You can see, oh, that's a typing error. That's a typing. Oops, what's happening? Inspects bridge. Yeah, then you can get a whole bunch of information about that specific network. Yeah, that is how you inspect networks. But this time around, we can also inspect a container. Yeah. Typically, how you'd go about doing this, you'll do, okay, let's go back to this screen here. And we can see, let's say, for example, we wanted to investigate this container, the first container, which is currently up and running. Yeah, we can, let me copy that container ID. To go about that, you'll need to do docker RMI, then, oops, actually not RMI. RMI is for removing an image. Docker inspect, then container ID. And it will give you a whole bunch of information about that specific container, starting from network settings to mount points, volumes attached, so much things. Let's see what it has to offer. We can see, okay, it was created at a specific time, and the command run or the path used was bin bash shell, and the current status, we can see it's running. Okay. Other relevant information includes the image ID, the log path. If you wanted to check the logs specifically for this container, basically we will need to go to this path. Actually, let's try seeing whether we can access those logs. I remember Kevin asked that question last time. Let's try see whether we can look at the logs. Yeah, we basically don't have anything on that container since we didn't do a lot. We just ran the ID command, and that was that. But that's, I think the log file looks something like this. So back to these properties here. What else is interesting to know about? We can also check other stuff like, okay, it's named as a test server, and so many other things that maybe I cannot finish talking about. We can see there's a whole bunch of stuff related to this specific container. So typically that's how you'd go about inspecting specific container properties. And now you can see network settings. It's using a bridged network, but we can also choose to run a specific container using maybe something like we have like three networks. Yeah, if you don't want to run a bridge network using the default bridge network, we can also try attaching a different network. I'll show you how to go about that, don't worry. So yeah, the IP address assigned to that machine is .2, and the MAC address, and so many other things. Yeah, so that's how you basically inspect containers. And I'll explain something about Docker security and talk about the inspect command once again. I'll talk about it. So let's say let's now work with images. As you can see, we have these images once again, and let's assume we want to remove the CentOS image that we just pulled. So as I have said, we can do this by running the Docker RMI, and then we can use the container name. Let's say, for example, CentOS, or we can try using instead of using the repository name and the tag, we can use the image ID. So in this case, it will be that way. But if I run this command, it will not actually remove this image. It will spit an error, and I'll explain why. Yes, we cannot remove this image currently because it's currently in use by what container? By this container called 7D17. And if we try looking at that, if we try looking at containers, Docker PS stack A, if we try looking at those containers again, we're being told that this specific container is actually using that image. So that's the reason why you cannot, this one, since this machine is as you can see, it's currently up and actually it's not only one container. We have two containers which are running, and this will make the removing process quite impossible. So what we can do in this scenario, we need to stop these containers first of all if they are running, and to do so we can use the docker stop command. If we can use the we can use the docker stop, and we can actually do multiple. We can actually remove them on one command. You can do container ID this, then space, then I also want to remove this container, and I'll paste it there. And I think that should stop those containers from running. If we check the current status once again, Docker PS stack A, it should tell us they are stopped. Yeah, higher. If we try removing that image again, I believe it should spit the same error, because these containers, yes, have been stopped, but we need to also remove these containers completely. So aside stopping them, we also need to remove them. And to do so, once again, we use the rm command, and we have managed to stop to remove them, and we can check the status if they are currently still there. They are not there. So if you run the docker rmi container, the docker rmi command again, it should remove that image completely. Yeah, and we have managed to delete it, as you can see. And if we check our images once again, we should not see it there. Yes, that's how you'd go about removing a specific image. You typically, if you had some containers built, maybe let's say running, or they were exited, they were in the exited they had the status exited, you need to first of all remove those containers. Then you first of all have to stop them if they are running. If they are not running, you need to remove them. Then you need to remove the image. That's how you'll go about removing the final image. Yeah. So I don't know whether there's something else maybe I can add. Okay, yes, there's something else you can also do. So I'll just run this again, docker ps stack a, and also do docker images. Yeah. So let's say, for example, I have a container called production server, and I have a container, yes, called production server, and I want to save this. Let's say I have someone like Kevin who wants to. I want Kevin to test this this specific container. So there are many ways I can get this container to Kevin's machine. One of the ways is saving this file, this container, in form of a zip, of a table. Let's say like a compressed format. Yeah. Alternatively, I can upload this image. I can upload that image to the Docker Hub, and then Kevin can use the Docker pull and the container name command, and they can pull that image to their local machine. So in this case, that's like a tedious process. What I'll typically do is save that container in form of a table. And how will you go about that? You can run the docker save command. I believe save, yeah. When you use the docker save command, you can save one or more images into a tar archive. And I'll show you how to do that. Let's say I want to export, these are quite big images. Okay, let's say I wanted to export the Ubuntu image to Kevin. I will do something like docker save. Then I want to save it as maybe Kevin.tar, and which image you need to specify which image you want to save. So in this case, it's the Ubuntu image. It's the Ubuntu image with the tag latest, right? Latest, and that should be very, very fast. Let's see. Yes, that's that. Maybe you can try see whether it's grab Kevin file. It's there. It's not there. Oh, grab here. Yeah, you can see that we have managed to save this file as Kevin.tar. Yeah. So let's assume Kevin now got this. I don't want to ruin this. What we can do is, okay, let's assuming that Kevin got this the compressed format for the Ubuntu image. So if Kevin wanted to load this image to his system, he will typically have to use the load command. Yeah. So the load command loads an image from a tar archive to stdin format or something like that. So Kevin will typically have to do something like docker load, and I will use the tag I, and in this case I want to load this image called Kevin tab. So just give it a minute, and it has loaded that image successfully. And if we do Docker PS, Docker images, we should see that we have two instances of that image. Actually, did it load? Image. Okay, did not display. Let me show you how to go about that. I'll have to remove this Docker, the Ubuntu image. Sure that, stop this container. I'll end that container. Then I want to remove this container. Yes. Just a moment. Okay. I wanted to Docker PS stack A. Sorry. Stack A. Yeah, we only have one. Okay, so we can proceed to remove Ubuntu image so that we can load it afresh. Sorry, Docker images. Yeah, Docker RMI, and we can try using the image ID this time. It has independent child. Oh yeah. Okay, we can try force it. It cannot be forced. Why? Oh, I cannot be able to remove this image because I built this image out of this Ubuntu image. So that is not going to be possible. So basically, what Kevin would have done is docker load stack I and just load the tar file as follows. I don't know why it's not loading, but loading image Ubuntu latest, yeah. And when he does Docker images, it should reflect the loaded image here. Yeah. So that's how you will basically export and import Docker images. Something else that I have not talked about is that renaming this Docker tag. Yeah. So let's say I wanted to rename this instead of calling it Ubuntu latest, and I want to call it, or we can try rename the first container. So we have an image called Oste, my toolkit. I wanted to rename this to rename its tag from maybe version 1 to version 2. I can simply do that by running docker tag, and I will have to put my repository name followed by the current tag, which is version 1, and I also want to give it a version tag of 2. So hit enter, and if you check Docker images again, you will see that actually it created a version 2 of that image. So that's pretty awesome. So, but the thing is, we have 2 versions, okay, but they have the same image ID. This can bring about complications. So in renaming, you have to remove one instance of that image. And in this case, I don't need version 1 anymore. So I'm going to terminate it, but it can bring a problem since, let's see, we can try using RMI. Then I want to remove the specific one with a version 1. I think it should work. Yes, and we have untagged it. Run Docker. Run Docker image images. We should see that we have the current version now, which is version 2. So basically, that's all I had to share on Docker today. Unless you need any clarification, I welcome any questions. maybe somewhere you've not understood, I can try repeating the same. Anybody, if you have a question, please ask. Docker is actually really fun. If you start playing around with Docker and experimenting a few things, it's really fun. Maybe in the next session, I'm going to show you how now to create your own images. Yeah, don't know that you can try create an image here. Let's try. We can try creating an image, but then I'll go into depth the next time. Let's see. So maybe you don't have questions, but let me just give you a scenario. You'll probably ask, okay, so why Docker? Yeah, like why is Docker first of all popular in organizations that deal with that maybe make applications or stuff like that. So basically, it's very easy for developers to package code. Yeah, it's easy for developers to package code on containers and maybe deploy them or ship them to the public or to other members, other developers, so that they can work on the same project. I don't know how to explain that, but basically Docker is very easy to package and create package code. Yeah, and I'm going to show you how. For example, I'll assume I have a very simple project that I have created, and we are going to package it, and we're just going to build a whole image out of a simple file. So how to go about this is just a minute. Let me open that code. In the meantime, if you have a question, you can always ask. Okay, so I'll show you. I think I will show you two ways that you can use there are actually two ways that you can use to build a whole container, right? I'll show you this, then I'll give you maybe like an assignment, or for practice purposes, I'll let you go and experiment more, or maybe try get some. So maybe you can try get a code from someone on the internet and maybe try build that image. Yeah. So simple thing that we can do here. Okay, let's go to the desktop directory. Okay, in the root, let's make a directory called code, and change to that directory. So I'll do Docker images, and yeah, let's create a container based on Ubuntu. In this case, I will do something like Docker run. I want to get an interactive shell. Then I want to name this container as I'll call it what do I call this container? My name, my project. My project. Then something else. I want to run this container based on Ubuntu image with the tag latest, and I want not latest. I want latest, and I want to run it with a bin bash shell. Bin bash shell. I think that should create it, and maybe you can. Huh? Docker Run interactive project. Oh yeah, we are inside that container. So we can maybe do something like what can we try installing? Apps. Install Vim. Okay. What's the problem? What? I cannot do anything. Maybe you can try create a file. Touch test.txt. Awesome. Yeah, we have it there. So we can exit out of this container. And one thing I want us to note is, okay, let's see, Docker ps stack a. Yeah, we exited successfully. So if I wanted to build, you see, this is currently a container. This, my project here, is a container. But if I wanted to build an image out of this container, let's say, for example, you might have, maybe I can show, I don't know whether I can show you something and try explain what that person did. We have a tool called, I think, Bug Bounty. Toolkits. There's a tool called by Hackersploits. Yes, there's this Bug Bounty toolkit. So what Hackersploit did, he has some tools that are pretty awesome, that you can basically pull this image by running this command, then running it, getting an interactive shell, whatnot, bin bash or a shell. I don't know how you pronounce that. Yeah, you can basically run with that kind of a command. But let's say he has installed tools like Nmap, RustScan, I don't know who is Dig, all those tools. So basically same case, we can assume you have done all that inside that container, and now we want to have that container in the form of an image, such that other people can get to use this image. Yeah, for example, we have this Docker, I think Docker images. You can see we have the first image that I have here is actually, it was a container that I created. I first created a container, then I installed some tools in it, like Nmap, basic tools like if config, all those tools that you can think of that are maybe necessary for hacking and stuff. So out of that container, I built this image. Yeah. So if I wanted to export this image so that you guys can also get access to it, I just push it to the Docker Hub, and you get to enjoy my image. So I'll show you how to create an image. So assuming that you'll create your own image, and maybe you start installing tools like Whois, AMAS, all those tools, and you want to build it into an image. So how do you go about this? So I want you to notice when we're inside that container, we had a name and we had this number here, this name here. So this is basically what we need in order to create an image out of that container. Not confused using this number, and you go ahead and use, actually it's the same, it's the image ID, it's the container ID. So we basically need the container ID in order to build an image. And how will you go about that? We'll do something like Docker commit. Yeah, and that's a typo there. Something like Docker commit, and maybe Docker commit something here. Yeah, commit. Docker commit, you create an image from a container's changes. Yeah. So assuming that container, you have installed a lot of tools in it, and you want to now build an image, you will use the commit command. So Docker commit and the container ID. In this case, then you think it should be very fast. And we have already managed to create our first image, Docker images, and we should see that, yes, we have created an image, which is almost similar size with the Ubuntu image. But you see, for example, in my toolkit, I built it out of an Ubuntu image, but as you continue to install stuff in it, the size increases. So we have not currently installed anything in this image. Yeah. So typically what I'll do I have now to name this container. I mean this image, and also give it a tag because it's currently blank. Yeah, but we see we have its image ID. So how you'd go about doing this? You need to tag it. You need to use the tag command, and you need to run something like docker tag. Docker tag. Then you use the image ID followed by the name you'd want to give this image. So the recommended and the best practice to do so is first of all, you see, I named it Oste because that's my name on my Docker repository. So typically I'll still do the same thing. You don't have to, you see, like Hackersploit, they built this toolkit and they first named, you have to name your container first. You start, first by using your repository name, then the name of your tool or the name of your code or your project. So in this case, I will start once again with I will still start with my repository name, followed by, let's call it nmap, or no, projo. We can call it projo. Yeah. And we also want to tag it with we want to give it a tag of maybe version 1, right? So hit enter. Oops. Oh, sorry, I put that naming convention. Yes, that should work. Docker image is, and you should see that now we have an image called Oste Projo. Yeah. And let's say I want you guys to access this image. What I'll typically have to do, actually, I'll give you this as an assignment. So let me just upload it to the Docker Hub. But in order to upload it to the Docker Hub, we first of all need to sign in to your Docker Hub on the terminal. So I'll do something like Docker login, and I'll need to put my username as Oste, and I hope it doesn't show my password. Yeah. Password. That's correct. Login. Yes. Once you log in, like how you log in to your how you log in on the hub.docker. So you use similarly, you just use those credentials on the command line, and once you log in, now you can be able to push that image by simply doing docker. I think it's docker push. Yeah, docker push, and we name this project as Oste, and just going to do projo, and it had a version 1. Yeah, I think that should work. Let's see whether it will work. Yeah, so it start pushing this project to the repository. I want us to see whether it will actually reflect it here, and I can send a link. Then I want you to make some modifications to this. You'll simply, on your end, you'll simply need to pull this image from let's see my profile. Yeah, it's actually uploading, or maybe it has finished. I don't know. Yeah, we have managed to push that image. So currently you can see its status, it's private, but if I wanted to make it public, I can simply just go there and let me update it a second ago. Manage repository. Let's see. I want to make it public, and you can see some properties such as, okay, it has a tag of version 1, and you can also see that its operating system is a Linux. it's built out of Linux. If I wanted to create a simple README, I will simply have to do so here. Similarly to how you have seen that in the bug bounty toolkit thing. So basically what you'll need to do, you'll have to, as an assignment, you'll maybe need to pull this project to your local machine, create a container out of this project, like how we've done, create a container out of this project, try installing some basic tools that you come across. Maybe let's say something like Nmap, those let's say like tools you typically use quite a lot. Yeah. So you see, the good thing about having such a toolkit as a container is that you can easily access it anytime. Let's say, for example, I don't have access to my Kali machine, but I need all my tools. If you have a machine, if I have access to your machine and I don't have my machine near me, I can easily pull my project from the Docker hub, and I can simply run those tools that I would have needed that were in my machine. So Docker makes some things easier. That's why I am quite focusing on learning Docker, because you can do quite a lot with it. It can make your life easy, and you can create quite a lot with it. You can create your own like your own toolkit. Yeah. So that's one way of creating an image. I don't know whether there's a question up to that point. Is there?
I have a question.
Sure, ask.
Hello.
Yes, I can hear you. Ask.
Yes, if you want to install a tool like Nmap to a Docker image, do you still do it the same way that you do it on the regular operating system?
If you want to install if you want to install Nmap on a container.
Yes, on a container. Yes, that's right.
It is still the same thing. It is still the same thing, because you know you're actually getting a shell on an actual operating system. So it's not like you're going to run any different commands or something like that. You get?
Yes.
You get? Yeah. Okay. So that's yeah. Okay, you're welcome. That was one method for creating containers. Yes, this other one is a bit complex, but not really that complex. I can show you a simple project. I don't know whether I have that code here. I don't think I have that code here, but maybe I can show you on the next session. So don't worry about the other one. You need to use something called a Docker file. Yeah, I'll show you how to code a Docker file. But that one basically you have to maybe write some piece of code for that in order to run. But basically, let me show you what a Docker file looks like. I don't know whether we can. We can try look for something like Hackersploit. Yes, this one. Yeah, Docker file. Yeah, he has a Docker file here. Actually, we can try create an image, our own image out of this Docker file. So this is how a Docker file looks like. Basically, what you need to do is very simple. Instead of manually having to start writing, to start installing pieces of code, you can simply do all that automatically by writing such a script. Yeah. So basically, let me try explain a few things out of this. You can see he created this his toolkit from an Ubuntu 18.04 image, and the label maintainer is his name. There's something called a label maintainer, which is his name, and he set some environmental variables. I'll talk about that next time. and his working directory is root. And when we run this Docker file, what basically it will do, it will first of all run an update, then it will install all these tools. And you see they are basic tools like he installs Tmax, it installs GCC compiler, it also installs Git, Vim, Wiget, curl, make, nmap, whois, basically simple stuff that you'll typically need to use on a day-to-day activities. Then we can also see he also installs some dependencies. For example, he installs a tool called dab, another one SQL map. You see, he also installs another tool, very many tools, basically Hydra. Also seeing DNS Recon and a lot of other tools. And a lot of other complicated stuff that maybe I will not talk about today, but I'll show you how to create such a file next time when we meet, right? So if we were to save this file and try running it, we will create we'll basically have this image that we had seen earlier. Maybe I can try open it in a new tab. Yeah, we will basically have this image. Yeah, so you can do quite a lot with Docker. Docker is fun, Docker is interesting. Go ahead and maybe learn it more for your own. That's for your own, like it's like a plus nowadays to get to know containerization technologies. It's not only Docker, we have other containerization technologies. We have Kubernetes. Maybe I don't know who's good in Kubernetes. Maybe you can have a session sometime and teach us something on Kubernetes. But Kubernetes is like an alternative to Docker. So yeah, that's how you go about building an image. I don't know if anybody has any questions. Anybody who has a question? Teresia. Teresia. Teresia.
Yes,
How are you doing?
I'm fine, thank you.
Were you following? I lost you along the way.
Nimefollow, yeah, nimekuwa nikifollow and then si unasikia tu sauti hapa back.
Yes.
Hapa nyuma. So
Yeah.
like nimefollow and it's good. Penye najua tu sijaelewa, I will still get back to you.
Awesome.
Najua nitafollow up too in the office.
Yeah.
But it was a nice session. At least nimekata up. I've been there. Like for today, I've been there throughout.
And thanks for attending.
Yeah, thank you too for also getting that chance and creating time to at least help us learn more. At least I'm loving these sessions and I'm also learning more. I'm also looking forward to learn and get to know more. Yeah.
Okay, awesome.
Thank you, Steve.
Karibu sana.
Asante.
Kevin Naftal.
Yes, I'm here.
How was the session?
It was good, although kuna blackout hapa hivi, I'm not using my machine. I've been just following and taking some notes.
Okay.
Yeah, so I will have to do it practically by tomorrow. Then any questions